Welcome to Lesson 8. Hopefully by the end you'll be able to identify how changes in constants of a quadratic function written in vertex form affect the graph of the function. We've talked about vertex form already, so we're going to kind of review it a little bit today. And let's kind of move forward. So take a minute, pause the video, make sure you write down your SWOT, okay? And let's move on. All right, just think about it. I want to see it in your notes, and I want you to do your graph, all right? And hopefully you remember how to plot points. Your point should always include the origin, all right? Sorry, make sure you include your vertex, guys. I was looking at this one and going, oh yeah, the vertex goes to the origin. But yes, include your vertex in your points if you make for your table, all right? This is kind of an introduction into something we call parent functions. X squared, the graph of x squared is the parent of all quadratic functions. And we can get them by doing transformations on that function x squared. By shifting it left, right, up, down, and changing how fat or narrow our graph is for our quadratic. And there's special ways of looking at that. So I'd like you to pause this and do this, all right? It says use your calculator to verify, to check your thoughts. When you come back to class, we will have the calculators out, and you can check that as soon as you come and sit down in class, all right? You can be doing that. I expect to see this all in your notes, right, guys? Completely in your notes. Completely. All right. All right, here is the quadratic, the vertex form of a quadratic function, all right? And we know things already about this, right? What do we know already? We know that our vertex is the point HK, right? And we know something about A, right? So if A is greater than 0, we already know that my parabola opens up, right? It looks like this. And if A is less than 0, it opens down. It's unhappy. Looks like that, right? Because it's less than 0. You've already established this, but what's special about HK, our vertex, that actually, this corresponds, HK corresponds to our transformation, a horizontal and vertical transformation. So HK corresponds to a horizontal and vertical translation. What does that mean? Well, let's think back to geometry. All right, translations are things that are kind of like, not slides, but often they're thought of that way. And what does that mean for K? What does K do for our graph? That's the Y value, right? So what do you think K is going to do? It's going to shift our graph. It's going to shift the graph up or down, right? Hopefully, by the end of the lesson today, you can figure out which way. And that means that H is going to do what? Well, look at what H is affecting. Look at what it's working on. H is affecting the X's, right? And the X's are on the X-axis. So that means what I'm going to affect is whether I'm going left or right. This is left or right. Okay? A, it actually does more than what we've said here. It has some other special properties. and I want you to discover the properties of A as we work through our problems today, all right? Hopefully you can come back and tell me. I want to see in your notes, right? I want to see in your notes, I want to see how, I want you to answer the question, how else does A affect my graph of f of x? Okay, I want to see that answered in your notes. You should be able to answer this by the end of the lesson today, all right? So let's take a look at our first problem. All right, so here's the first one we want to try together, okay? Whenever I'm looking at these graphs, what I want to do is I want to identify the transformations of the graph, all right? Based on the formula that I have for my equation for my function. So I want to know what transformations I have going on here. All right, so let's look at this and try and figure this out. We know the vertex is what? The vertex is going to be the point 3, 2. Well, that means my graph was shifted. If you did the think about it question, you know that y equals x squared. Y equals x squared has a vertex of 0, 0, right? So if we look at, we started at 0, 0, and we shift to 3, 2, that means we went right 3 and up 2, okay? So we went right 3 and up 2. Are we opening up or down? We are going to open, because 1/2 is greater than 0, we're going to open up, all right? But there are some other things we need to think about here in a minute, but I want you, let's just kind of plot some points first, all right? So I want to graph this equation, and in order to graph it, we need to plot some points. Whenever you graph, I want to see 5 points, all right? And in those 5 points, I always want to see your vertex, all right? So we have our values for our graph. Let's see. So we have x and we have f of x. Okay? You always, well, this is how I like to do it, okay? I like to start with the vertex because that's easy to find. The vertex here was 3, 2. Then I look at my equation and I go, okay, what values can I plug in there to make it easy to work with? Since I'm subtracting 3, then I can go and the next number that is going to work out nicely if I'm going to divide by 2 is 1. So I plug in a 1, and 1 minus 3 is 2, squared is 4, divide by 2 is 2, add 2 is 4. Okay? I picked that because I wanted the difference to be an even number, because when I square an even number, I get an even number because I'm dividing by 2. All right? And I also pick -1, and I get 10. And because this is a parabola, it's something we call symmetric. So at 5, I get 4, and at 7, I get 10. Hopefully you can see the pattern here, gentlemen, in the numbers. If you don't see them yet, you'll see them in a minute. So let's graph this. All right, so here's my graph. There it is shifted. Just so you can see what the parent function looks like real quick, let's plot that so you get an idea. So that's at 0, then 1, 1. Then the next one would be 2, 4, right? 2, 4, right here. And then 0, 1, 1. Oh, sorry. I messed up 1, 1, didn't I? Let's get that fixed. So here's 1, 1. Come on. Come on, there we go. 1, 1. Negative 1, 1. And the next one would be at 2, 4, right there. Okay, we connect the dots. It goes up like that. Something like that in baby blue. Sorry, it's not the best, but there it is. So we took that little graph, that little blue one, and it became that brown one next to it, okay? Let's try another one. Hopefully you know how to plot the points and you saw the transformation here between the shifts, right? So let's take a look at the next one. All right, so here's the next one. What I want to see from you guys is, can you tell me what the vertex is, all right? Write the vertex for me. What is the vertex? The vertex is, we should have all gotten -2, -1. All right? And if you're asking about that -2, remember the form it was x minus h. So if I have a plus inside, that means that it was negative. Two negatives make a positive. That's why it's positive inside, okay? So that's my vertex. That means what? If my vertex is -2, -1, that means I shifted how? All right, good. So that means we went left 3 and right, so we went left, how much? 2, right? Left 2 and down 1, right? That's how we shifted, horizontally and vertically. And again, we're not sure exactly what that 3 is going to do to our values, but let's think about it for a minute, all right? And think. If the last one, right, we multiplied by 1/2, and those are the numbers we got, right? Let's see what happens this time. So let's draw our table and fill it in. All right, again, I always start with the vertex in the middle of my table, and then I picked easy numbers to plug into. Because I'm not dividing by anything, I'm just multiplying by 3 on the outside. It made sense just to pick the next numbers, right? -1 and 0, and -3 and 4, and plug them in and see what I get. And when I do that, I get the values 11 and 2, and then that would be 2 and 11. All right, so now we want to plot that and see what we get. All right, so look, I graphed it. I was pretty fast, right? So good, so quick. So in green, we have our original function, f of x, and in purple there, that's the parent function, x squared, all right? So I notice that I graphed my 5 consecutive pairs just as well in green and in red, so you can better see exactly what that 3 is doing to my graph, right? What exactly is that 3 doing? I hope you can visualize it and see what's going on here. All right, let's try another one. Well, actually, I think this is good, right? If this one, look at it. It kind of, what did it do to my graph? What did it do to my graph? Think about it. What did that 3 do? Oh, and I have a 1/2. What did that do? Right? Notice there's a difference between these two, right? One is 3, one is a 1/2. One looks thinner, the other one looks fatter. So what exactly is that 3 doing? And is it affecting, what values of my function is it affecting? Is it affecting the x's, or is it affecting my output, my y values? Okay, I want you to think about that. All right, and I want you to come up with a rule for what this A does, all right? Hopefully we can see it here with these two, but in interest of keeping everything, in a nice, neat, short time, we're gonna we're going to skip our next example because I think 2 is enough for you to see how to see the transformations here and draw the conclusion for 3, right? If A is negative, again, it opens upside down, right? It's unhappy, it opens down. So you should also take note of that A, right? If A is negative, that's reflects it across the x-axis is technically what we call that. Reflecting across the x-axis is what the negative does. Okay, so let's move on. And on your own now, I would like you to write out, what the transformations are here. So at this point, you will have had to have discovered what 1/2 and 2 do to my function. Hopefully you came up with it, and if not, I still better see an answer for how it affects it, right? Because at this point, you all know what those things do to it, okay? And you know what that negative does and all those transformations. You should know, okay? It isn't really too bad. So have fun with this, guys, and I will see you later.